Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video we are gonna learn how to calculate compound probability of independent events, and we are gonna solve several examples as always. Okay, without wasting any more time, let's jump into today's lesson. The first thing that we need to learn in this chapter is the definition of independent events. What does it mean, independent events? Events are independent if the outcome of one event does not affect the outcome of other events. Okay, what is the meaning of this definition? Assume that I'm flipping a coin and rolling a die at the same time. Or first I'm flipping a coin, then I'm gonna roll a die. So here I'm gonna have two events. When I have more than one event, I call it compound events. So this trial is a compound event. Second of all, whatever I get from flipping a coin, for example, heads or tails, it does not matter. Whatever I get, is it gonna have impact on the result of the second test, which is rolling a die? Of course not. They are separated. They are not related to each other. So I can realize that these two events are independent events. Okay, what should I do for solving probability of independent events? We are gonna learn two different methods, and I'm telling you now, the first method is time consuming and the possibility of making mistake is really hard. But because I want to have a complete study plan, I need to mention that anyway. What is the first method that we need to learn? Writing the sample space for all of the events, then using the formula. Which formula? The formula that we had for calculating the probability. P is equal to number of favorable outcomes divided by number of possible outcomes. Okay, let's solve some examples with using this stupid method. Using the sample space method, it means the stupid method that I just told you. Find the probability of getting one heads and one tails in two coin flips. I'm sorry. This is gonna be the first coin and this is gonna be the second coin. I'm gonna flip those two coins. Okay, what should I do now? I must write the sample space for all of the events. I'm gonna write the possible results based on order pairs. So the first thing that I have is getting heads from the first coin and getting heads from the second coin. The next one is getting heads from the first one and tails from the second one. Tails, heads, and finally tails from the first one and tails from the second one. These are all the possible answers. Now I'm gonna write the formula of probability. I want to find the probability of what? Heads from the first one and tails from the second one. So I'm gonna show it with H, comma, T, exactly like an order pair. So how many favorable outcomes do I have here? As you can see, I have only one favorable outcome, getting heads from the first trial and tails from the second trial. I'm gonna write it in the numerator. How many possible outcomes do I have here? If you count the number of members of sample space, you would realize 1, 2, 3, 4. We have 4 possible outcomes, and if I multiply it by 100 to convert it to percentage, I would realize that this probability is going to be equal to 25%. Really easy. Using the sample space method, it means the stupid method. Find the probability of getting heads on a coin and rolling 5 on a 6-side die. So I'm going to have a coin and I'm going to flip it, and I have a die and I'm going to roll it. I have more than one event, so this question is related to compound events, and these events are not related to each other. They are not going to have impact on the result of each other, so they are independent events. I'm gonna write the sample space. It means all the possible answers. What are the possible answers? Again, I'm gonna write them based on ordered pairs. So the first possible answer that I have is getting heads from the coin and getting 1 from the die. I'm gonna continue that. Getting heads and 2, getting heads 3, getting heads 4, getting heads 5, heads 6. Now we are gonna move to tails. Tails 1, tails 2, tails 3, tails 4, tails. I'm sorry. 5 and tails 6. Congratulations. After wasting a lot of time, finally I wrote all the possible answers. Now I'm gonna write the probability. Probability of what? Getting heads from the coin and rolling 5. Okay, how many favorable outcomes do I have in the sample space? This is the only favorable outcome that I can find in the sample space. So I'm gonna have 1 favorable outcome. And how many possible outcomes do I have? The only thing that I need to do is counting the members of sample space. Okay, let's do it with each other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 1 over 12. And this is the answer of this example. Using the sample space method, it means the stupid method that we talked about it. Find the probability of getting tails on a coin. So I have a coin and I have a die and I want to get a number which is greater than 4. First of all, how many events do I have? As you can see, I have 2 events. One of them is related to flipping a coin. The other one is related to rolling a die. So we have compound events. Second of all, flipping a coin. Is it gonna have impact on the result of rolling a die? Of course not. So they are independent events and we want to use the method which we call it sample space method. So let's write all the possible answers with each other. The first possible answer that I have, again, I'm gonna write them based on ordered pairs. Heads and 1, heads and 2. This is gonna take a time. Heads and 3, heads 4, heads 5. This is not difficult, this is just time consuming. Heads 6. Let's move to tails. Tails 1, tails 2, tails 3, tails 4, tails 5, and finally tails and 6. These are all the possible outcomes that are members of sample space. Okay, I want to find the probability of getting tails and rolling a number greater than 4. So I must write greater than 4. Greater than 4 means 5 and 6 on a die. Okay, let's find the number of favorable outcomes with each other. These are heads, so we have nothing to do with them because the first thing that we need to do is getting tails. So this one is tails, but tails and 1. I want greater than 4, so this one is not included. Even the 4 is not included because I want to find a greater than 4. But this one, getting tails and 5 is included because first of all, I got tails. And second of all, 5 is greater than 4. I have the same scenario for the last member. So how many possible answers how many favorable outcomes do I have? As you can see, I have 2 favorable outcomes. And how many possible outcomes do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 over 12. If I simplify that, I would realize that the answer is going to be 1 over 6. This is the answer of this example. Really easy. The second method that we are going to use for solving probability of independent events, and it is really better method, and I strongly suggest you to do this method because the possibility of making mistake is really less and it is less time consuming, is using this formula P of two events which are independent. It means they are not going to have impact on each other. Is going to be P of A and B is going to be equal P of A multiplied by P of B. The first example that we have here, we are going to roll a red die and we are going to roll a blue die. What is the probability that red die shows 3? So I'm going to write like this, P of 3, and blue die shows even. So this 3 is related to red die, and this one is the even number is related to blue die. I'm gonna find the probability of each one separately, and then I'm gonna multiply them by each other. So the first one that I need, the first probability that I'm gonna find it is probability of getting 3 in red die. Let's write the sample space for the red die. S is gonna be 1, 2, 3, 4, 5, 6. I expect you to know that it's not necessary at this point to write the sample space. Okay, how many favorable outcomes do I have? As you can see, I have one favorable outcome. And how many possible outcomes do I have? I have 6 possible outcomes. So it's gonna be 1 over 6 for the red dot. And let's find the even in blue die. Again, I need to write the sample space. If you know that, you do not have to write it. 5 and 6. We want to get even, so how many favorable outcomes do I have? 2, 4, and 6. And how many possible outcomes do I have? And of course, we have 6 possible outcomes, so it's gonna be 3 over 6 or 1 over 2. Now I calculated the probability of each one separately. The only thing that I need to do is multiply them by each other. So 1 over 6, which is the probability of getting 3 in a red die, and if multiplied by 1 over 2, which is the probability of getting even number in a blue die. If I multiply them, the answer is gonna be 1 over 12. Really easy. It's easier than previous method. You roll a red die and a blue die. What is the probability that red die shows a 5 and blue die shows either 1 or 3? So I'm gonna write find the probability of getting 5, which is related to a red die, and 1 or 3. These are related to the blue die. For solving this example, I'm going to skip the part which is related to the writing of the sample space because I assume that you know that. So probability of getting 5 in a red die. How many favorable outcomes do we have? I have only one favorable outcome, which is 5. And how many possible outcomes do I have when I'm rolling a die? Of course, I'm gonna have 6 possible outcomes. So this is the probability of first one, and probability of 1 or 3 in a blue die. How many favorable outcomes do I have here? 1 or 3. So I have 2 favorable outcomes. And how many possible outcomes do I have when I roll a blue die? It's gonna be 6. So 2 over 6 is gonna be 1 over 3. What should I do at this point? The only thing that I need to do is multiply them by each other. So 1 over 6 times 1 over 3 is gonna be 1 over 18. And this is the answer of this example. A bag contains 2 A cards, 3 B cards, and 4 C cards. You pick a card at random, replace it. This is the word that change everything. And then pick another card. What is the probability of picking an A first and a C second? So I want to find the probability of A and C. Why did I tell you that replace it is the word that changes everything? Assume that I'm gonna take A from this bag and I'm not gonna replace it. What would happen? The sample space is going to change. Whatever I get from the first trial is gonna have impact on the second trial. So if I didn't replace it, it wouldn't be independent events, but I'm replacing it. So the first trial is not gonna have impact on the second trial, and they are independent, and I can write the formula of P of A times P of C. And I have a figure of this trial here. Look, how many cards do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, in the first one, I want to get A. How many favorable outcomes do I have? 1, 2. Okay, 2 A's. And the question has said that I have 2 A cards. And how many possible outcomes do I have? As you can see, I have 9 possible outcomes. And P of C, how many C cards do I have? The question says I have 4 C cards. 1, 2, 3, 4. I'm going to write it in the numerator, number of favorable outcomes. And how many possible outcomes do I have? 9. So the only thing that I need to do is multiplying them by each other. 2 over 9 times 4 over 9 is going to be 8 over 81. Really easy. Here you can find more examples, and I strongly suggest you to solve them at home. If you have any question or if you wanted to share your answer, please feel free and write it in the comment box. I will try to answer them as soon as it was possible for me. Thank you for watching this video.